Good morning to all. In this video, we will discuss a special instruction available in 8085 microprocessor that is called as STAXD. Actually, STAXD is an instruction. It's very useful for some cases that we will discuss with an example also. So the meaning of STAX is nothing but, so X means it is a register pair, which means D and E are represented here. A means accumulator, ST means store. So store the content of accumulator, store the content of accumulator to the address which is mentioned in the DE register pair. This is what is the meaning of STAX. So similarly, we have one more instruction. It is called as LDAX-D, which means accumulator will be loaded from the address which are mentioned in the DE register pair. For example, you just initialize the DE register pair with 4300H, and I am moving accumulator with 24H. Now when I say STAXH, what will happen? Accumulator content, that is 24, will be stored to the memory location which is mentioned in D register pair, that is nothing but 4300. So initially 4300 is equal to 0. Now after this, the result will be 4300 will be 24H. Now if you want to understand the LDA also, I just have initialized the memory location like this, and then I am incrementing the D register pair. Then the D register pair will be 4301, and then LDAX-D. So which means the accumulator is loaded from the memory location which is mentioned in the D register pair, that is 4301. So 4301 has FE, so that will be copied to accumulator. So this is the instruction. So what is the use of this particular instruction is, we are using memory pointer as HL register pair. HL register pair, the data available in the address which is mentioned in the memory pointer, that is nothing but HL register pair, is directly available in M register, but here it is not available in any other register. So that is the only difference. So let us see the example of a program with the transfer of block of data from a set of memory location to another set of memory location, which means I have a input data, about 5 data I have, which are stored in the 4200 memory location, 4201, 202, 203, 204. So 5 data are stored. So this has to be copied to 4300, 4301, 02, 03, 04. Okay, the same data has to be copied. So it can be done for any number of data, but the total number of data should be mentioned in the B register, or it should be mentioned. Then we are copying that, we are assuming that now 5 data are there and the 5 is copied to B register, and we are initializing HL register pair and we are initializing DE register pair. Now the content of M is nothing but 23, because HL is pointing out 4200, so therefore M is automatically take the value of 23. So the 23 is copied to accumulator. Now the content of accumulator will be stored to DE. DE means 4300, so directly 4300 takes 23, and then we are incrementing the HL register pair and DE register pair so that the next memory location can be accessed, and then the same data can be stored to next memory location in the DE register pair. So we are decrementing to check whether the data is being completed. Now it becomes the B register becomes 4, so it is not 0, it is continuing now. Again, now the content of memory is nothing but 4201. 4201 means 45 here, so that 45 will be available in the memory location, that is copied to accumulator. Again, storing the accumulator content to D register pair. D register pair, now the value is 4301. So which means that 4301 will be getting the value of 45 which are available in the accumulator. So we keep on repeating this until the number 5 is becoming 0. So similarly, if you want to transfer some 100 of data, 200 of data, 200 data, 300 data, or n number of data can be transferred from one set of memory location to another set of memory location. Thanks for watching. Whatever questions you have, you can post it in the comment box. I will answer all the questions. See you in my next video. Bye.